Okay, so we're just gonna quick go over some of the vocab that you need to know for this unit so that the start of the lesson tomorrow can go smoother. The first thing though that you need to know um, is what Mr. Loomer's and my favorite number is, because we have the same favorite number. Who's surprised? And I'm going to tell you that at the end of the video, so you need to keep that in mind for tomorrow in class. All right, so keep that in mind. I hope I don't forget. You have your blue vocab sheets. It says 411 notes at the top. So it's just a bunch of vocab that's going to come up throughout this unit. So I just want to run through it with you so that we don't need to do it tomorrow in class. So the first thing is just general probability, and some of this you guys might already know. So a probability, when you're talking about probability, we're talking about a number that's from 0 to 1 inclusive, meaning it can be 0 or it could be 1, or a percent from 0% to 100% inclusive. Again, could be 0%, could be 100%. Okay, that indicates how likely an event is to occur. You're not going to have negatives, so nothing below 0, and you're not going to have a number bigger than 1 or a percent bigger than 100. Okay, so over in the right-hand column, we just have some examples, or some of this will fill in. Probability of choosing a number between 1 and 10 is 0.1 or 10%, because you have 10 things to choose from, so 1 out of 10 is 10%. Okay. Experiment. An experiment is just any process or action that has observable results. So anything that we give you, picking a number 1 to 10, choosing a boy or girl out of a group of students, anything that we propose, pulling a card from a deck of cards, rolling a die, that's the experiment. Okay. The outcomes are the results of the experiment that you are doing. Okay. So if the experiment was flipping a coin, your outcomes would be heads or tails. Those are your options. Okay, so outcomes are kind of like what your options are. Your sample space is the set of all possible outcomes. So we're going to kind of focus on this, picking a number 1 through 10. The sample space for that is everything that could possibly happen. So if we're talking about an experiment that's picking a number 1 through 10, your sample space, every outcome that could happen, is obviously 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10. Okay. If your experiment is rolling a die, your sample space would be 1, 2, 3, 4, 5, 6, because there's 6 sides on a standard die. If your experiment was flipping a coin, your sample space would be heads and tails if you're just flipping it once. Okay. An event is the outcome or set of outcomes of an experiment. So again, we're going to use this picking a number 1 through 10 on here. So the event of picking an even number, so the possibilities, if I want to pick an even number out of this sample space, that's going to be 2, 4, 6, 8, or 10. Okay, so those are the probability, or those are the possibilities, excuse me, in that event. In the event of picking an odd number, your outcome possibilities are 1, 3, 5, 7, and 9. So again, I'm just using this picking a number 1 through 10 as my baseline, and that's what I'm basing this all off of. Your notation for that, if like O is a subset of S, so S is what we're pulling from, S being up here, picking a number 1 through 10. O is a subset of that. So what that subset means is that I'm pulling numbers from a bigger set of numbers. Okay, and that's the notation for that. You won't see that a ton, but it's there. Your element. An element is just an item or a member of a set, so that's what you'll see it referred to. Okay. So if we're looking at sample space S, again, going back up here, 4 is an element of sample space S. 1 is an element of sample space S. 7 isn't. So any of those numbers are elements in that set. Okay, so what is a set? A set is just a list or collection of items. So again, that's the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and your set, so set and event, we're kind of looking at the same thing. Your set of even numbers from 1 to 10 is 2, 4, 6, 8, and 10. Or we could look at the set of multiples of 3 from that. So this is going to be like a subset, but if our whole set is 1 through 10, and that's what we're focusing on, and I want to know the multiples of 3 from that, then the list of multiples of 3 is 3, 6, and 9. Multiples of 4 would be 4 and 8. So again, we're just focusing on the bigger set of just 1 through 10, which is where I'm getting all of those numbers from. Okay. So then on the back, so this is just kind of all your basics on the front. Okay. On the back, these are words you're going to hear a lot. So a union, you always want to think of the word or. When you see or and union, they're one and the same. Okay. So the union of sets E and M, which is denoted by, okay, this is what makes it easy. A union is a U. Okay. So when you see a big U, that is meaning union or, and it's the set of elements that are either in E or M or both E and M. Okay, so to make that a little bit more understandable, let's say one of our events is students who are 16 and one of them is students who are boys. Okay, so what is the outcome of A or B? So this is the U I was talking about. This is saying or. So this is saying what are the possible outcomes of students who are 16 or students who are boys? Well, what would satisfy that? That anyone at all who is 16 or a boy. Okay, so if I randomly were to pick one student and it was a girl but they were 16, then we would be okay because they just need to satisfy one or the other. The difference down here, so now you see intersection is and, so that's denoted by an upside down U. The way I remember that is if you were to throw a line through it, it'd be an A, and A is and. That's how I remember it. So now we're using the same A and B, students who are 16 and students who are boys, but when it asks what's the outcome of A and B, now that's a little different. Because now I'm looking for someone who is not only 16, but also a boy. So both need to be satisfied. So if I picked a random student and I was looking for somebody who was 16 and a boy, both of those need to be satisfied. So with an or, just one of them needs to be satisfied. With an and, both need to be satisfied. Okay. With your complement, the complement of set M, okay, this is noted by two different ways. You're going to see either M prime or you're going to see M with a bar over it. So you need to know both because they're kind of used interchangeably. Okay. The biggest thing with the complement is it's the set of elements that are not in set M. Okay. So if I have an event of A, students who are 16, and B, students who are boys, what is the outcome of not A? Or you might see it again as that. Well, event A is students who are 16. So if I'm looking for not A, I am looking for students who are not 16. So if we're thinking about our classes, I could pull a student who was 15, 17, or 18, or 14, and that would be okay as long as they're not 16. Okay. The last thing we're going to talk about in terms of vocab is a Venn diagram. You guys have definitely seen these growing up. Now, you've probably seen them a lot in English and things like that. So now this is just putting it together with probability. So remember, in this case, we have two sets. So we have set T and set G. So this right here is the overlap. So this is T and G. So where they're both happening. Notice this box around it. That box is representing your sample space. So you do always need to have the box because sometimes an item isn't going to fit in. So this is only T. This is only G. This is both. Sometimes it's not going to fit in any of those three places, and then it's going to have to go outside. So outside is not T or not G. Okay, again, those could be bars. Okay, so if it doesn't fit in T and it doesn't fit in G and it doesn't fit in the overlap, then it's got to go in the box outside. Okay, don't forget to draw the box. So we'll do that tomorrow with the lesson. Okay. Now, the answer to the question, Mr. Luber's and my favorite number is 6. You should remember that. It's both of our birthdays, so that's why it's our favorite number, and we're awesome.